Segmentation is the process of dividing a process into variable length chunks so that there is a maximum limit for the length of a segment. As we maintained the page number and the corresponding frame number in a page table, segmentation also maintains a table called a segment table, which consists of the length of the segment and the base address of the segment. The virtual address consists of two parts about the segmentation, that is the segmentation number and an offset. There is a serious issue in paging method, that is paging creates internal fragmentation due to its fixed length. But that problem can be rectified using segmentation because segmentation is of variable length, so that the file may be of any size, so that it can be fitted into the corresponding size of segment. This diagram shows how a logical address is converted into a physical address. As we saw in paging, the page number is represented in the logical address. Here in segmentation, the segment number is specified in the logical address. Few bits are given for representing the segment number. According to this example, 4 bits are used for representing the segment number, and remaining 12 bits out of 16 bits is used for offset. Once when the segment number is known, then we can able to retrieve the base address of the segment in the main memory. By adding the base address and the offset from the logical address, we get the actual physical address where a particular instruction is located. By using the length of the particular segment, we can able to calculate the starting address of the segment and the ending address of the segment. There are some advantages of using segmentation are listed over here. Some of the advantages are when the data grows due to some modification in the file, then the best method to use is segmentation. And when the file has to be altered, then again recompiled, and the data has to be shared and to lend protection for itself, then segmentation is the best method. Like page table, segmentation also maintains a segment table. There are 2 bits maintained in the segment table other than the length of the segment and the base address. Those 2 bits are the present bit and the modified bit. The present bit is used to set when the segment is available in the main memory, and the modified bit is set if there is any modification done in the content of the segment. This diagram clearly shows how to convert a virtual address to a physical address using segmentation. The first few bits in the virtual address are used to represent the segment number, and in the segment table there was a pointer called the segment table pointer is maintained to point out the first segment in the segment table. Now by adding the segment number with this initial segment table pointer, then it leads to the corresponding segment. For example, if the segment table pointer is pointing out to 0th segment initially, and the segment number represented in virtual address is 3, then 0 plus 3 leads to the segment table pointer to point out the 3rd segment in the segment table, which contains the base address of the 3rd segment and the length of the 3rd segment. By using the base address of the segment and combining the offset of the virtual address, we get the actual physical address of the instruction to be located. In real time, most of the operating systems use the combined approach of paging and segmentation. Since both paging and segmentation has its own advantage and disadvantage, it's better to use the combined approach. This is the diagram which shows the complete process of combined approach, that is using both paging and segmentation together, and how to calculate the physical address from the virtual address. So as we see here, the virtual address consists of three parts. The first few bits used for segmentation, number, and the second few bits are used to represent the page number, and the last few bits for offset. In this method, a segment is divided into a number of pages. That is, a segment is comprised of a number of pages, so that once when the segment number is known, then in that segment number, which page is that instruction is located, then from the page number, the corresponding frame number can be identified, and finally the physical address can be calculated. Let us take for example, the segment number in the virtual address is 3. Then from the segment table, segment 3 base address will be known and the length of the segment will be known. By using the base address of the segment 3 and adding up the page number from the virtual address, we get the exact page inside the segment. From the page table, the corresponding frame number is retrieved, and by adding the offset with the frame number, finally we retrieve the physical address of the instruction that is to be executed by the CPU. So this is a diagram which shows the format of virtual address, the segment table entry and the page table entry for the combined approach. So the virtual address consists of the three parts: the segment number, inside the segment which page number, and from the page number frame number is obtained, and finally using the offset with the frame number we get the physical address. In segment table entry, the entries available are control bits, the length of the segment, and the base address of the segment. In page table entry, we have present bit, we have modified bit, already we know the functionalities of these bits, and finally the frame number of the page.